Mifare is the NXP Semiconductors-owned trademark of a series of chips widely used in contactless smart cards and proximity cards. According to the producers, billions of smart card chips and many millions of reader modules have been sold. The technology is owned by NXP Semiconductors with headquarters in Eindhoven, Netherlands, and main business sites in Nijmegen, Netherlands, and Hamburg, Germany. The Mifare name covers proprietary technologies based upon various levels of the ISO IEC 14443 type of 13.56 MHz contactless smart card standard. Variants: the technology is embodied in both cards and readers. The Mifare name covers 7 different kinds of contactless cards: Mifare Classica, employer proprietary protocol compliant to parts of ISO IEC 14443-3 type A, with an NXP proprietary security protocol for authentication and ciphering. Mifare Ultralight, low-cost ICs that employ a proprietary protocol compliant to ISO IEC 14443-3 type A. Mifare Ultralight C, the first low-cost ICs for limited-use applications that offer the benefits of an open triple DES cryptography. Mifare DSphere, are smart cards that comply to ISO IEC 14443-4 type A with a mask-ROM operating system from NXP. Mifare DSphere EV1, includes AES encryption. Mifare DSphere EV2, includes MiSmart APP, Transaction MAC, and limited applications. Mifare Plus, drop-in replacement for Mifare Classic with certified security level. Mifare SAM Avenue 2, secure access module that provides the secure storage of cryptographic keys and cryptographic functions. Mifare Classic, the Mifare Classic card is fundamentally just a memory storage device, where the memory is divided into segments and blocks with simple security mechanisms for access control. They are ASIC-based and have limited computational power. Thanks to their reliability and low cost, those cards are widely used for electronic wallet, access control, corporate ID cards, transportation or stadium ticketing. The Mifare Classic 1K offers 1024 bytes of data storage, split into 16 sectors. Each sector is protected by 2 different keys, called A and B. Each key can be programmed to allow operations such as reading, writing, increasing value blocks, etc. Mifare Classic 4K offers 4096 bytes split into 40 sectors, of which 32 are same size as in the 1K with 8 more that are quadruple size sectors. Mifare Classic Mini offers 320 bytes split into 5 sectors. For each of these card types, 16 bytes per sector are reserved for the keys and access conditions and cannot normally be used for user data. Also, the very first 16 bytes contain the serial number of the card and certain other manufacturer data and are read-only. That brings the net storage capacity of these cards down to 752 bytes for Mifare Classic 1K, 3440 bytes for Mifare Classic 4K, and 224 bytes for Mini. It uses an NXP proprietary security protocol for authentication and ciphering. The Samsung Tactile NFC tag stickers use Mifare Classic chips. This means only devices with an NXP NFC controller chip can read or write these tags. At the moment, BlackBerry phones, the Nokia Lumia 610, the Google Nexus 4 and Nexus 10 can't read-write tactile stickers. Mifare Classic encryption has been compromised. See below for details. Mifare Ultralight and Mifare Ultralight EV1, the Mifare Ultralight has only 512 bits of memory, without cryptographic security. The memory is provided in 16 pages of 4 bytes. Cards based on these chips are so inexpensive it is often used for disposable tickets for events such as the Football World Cup 2006. It provides only basic security features such as one-time programmable bits and a write lock feature to prevent rewriting of memory pages but does not include cryptography as applied in other Mifare-based cards. Mifare Ultralight EV1 introduced in November 2012 the next generation of paper ticketing smart card IC for limited-use applications that offers solution developers and operators the maximum flexibility for their ticketing schemes and additional security options. It comes with several enhancements above the original Mifare Ultralight, 384 and 1024 bits user memory product variants, OTP, lock bits, configurable counters for improved security, 3 independent 24-bit one-way counters to stop reloading, protected data access through 32-bit password, NXP Semiconductors originality signature function. This is an integrated originality checker and is an effective cloning protection that helps to prevent counterfeit of tickets. Key applications: limited use tickets in public transport, event ticketing, loyalty. Mifare Ultralight C, introduced at the Carts Industry Trade Show in 2008, Mifare Ultralight C is part of NXP's low-cost Mifare offering. With triple DES, Mifare Ultralight C uses a widely adopted standard, enabling easy integration in existing infrastructures. The integrated triple DES authentication provides an effective countermeasure against cloning. Key features: fully compliant with ISO IEC 14443 parts 1 to 3, type A, 1536 bits EEPROM memory, protected data access via 3-pass triple DES authentication, memory structure as in Mifare Ultralight, backwards compatibility to Mifare Ultralight due to compatible command set, 16-bit one-way counter, unique 7-byte serial number. Key applications for Mifare Ultralight C are public transportation, event ticketing, loyalty and NFC forum tag type 2. Mifare DESFire. The Mifare DESFire was introduced in 2002 and is based on a core similar to Smart MX, with more hardware and software security features than Mifare Classic. It comes pre-programmed with the general-purpose Mifare DESFire operating system, which offers a simple directory structure and files. They are sold in 4 variants, one with triple DES only and 4 kilobytes of storage, and 3 with AES. The AES variants have additional security features, for example, CMAC Mifare DESFire uses a protocol compliant with ISO IEC 14443-4. The card is based on an 8051 processor with 3 DES AES crypto accelerator, making very fast transactions possible. The maximal read-write distance between card and reader is 10 cm, but actual distance depends on the field power generated by the reader and its antenna size. In 2010, NXP announced the discontinuation of the Mifare DESFire after it had introduced its successor Mifare DESFire EV1 late 2008. In October 2011, researchers of Ruhr University Bochum announced that they had broken the security of Mifare DESFire, which was acknowledged by NXP. See DESFire attacks. Mifare DESFire EV1, previously called DESFire 8, new evolution of Mifare DESFire card, broadly backwards compatible. Available with 2 KB, 4 KB and 8 KB NV memory. Other features include support for random ID, support for 128-bit AES, hardware and operating system is common criteria certified at level EAL4+. Mifare DESFire EV1 was publicly announced in November 2006. Key applications: advanced public transportation, access management. Mifare DESFire EV2, new evolution of Mifare DESFire card, broadly backwards compatible. New features include Smart APP enabling to offer or sell memory space for additional applications of third parties without the need to share secret keys. Transaction MAC to authenticate transactions by third parties, virtual card architecture for privacy protection, proximity check against relay attacks. Mifare DESFire EV2 was publicly announced in November 2013. Mifare Plus. Mifare Plus is a replacement card for the Mifare Classic. It provides an easy upgrade of existing infrastructures toward high security. Data management is identical to the Mifare Classic. However, the security management requires the modification of the installed reader base. Other features include 2 kbytes or 4 kbytes of memory, 7 or 4 bytes UID, with optional support for random UID, support for 128-bit AES, common criteria certified at level EAL4+, Mifare Plus S for simple migration or Mifare Plus X with many expert commands. Security upgrade with cards in the field. Key applications: public transportation, access management, for example employee, school or campus cards, electronic toll collection, car parking, loyalty programs. It is less flexible than Mifare DSVIRE EV1. Mifare Plus was publicly announced in March 2008 with first samples in Q1 2009. Mifare Plus, when used in older transportation systems that do not yet support AES on the reader side, still leaves an open door to attacks. Though it helps to mitigate threats from attacks that broke the Crypto 1 cipher through the weak random number generator, it does not help against brute force attacks and cryptoanalytic attacks. During the transition period from Mifare Classic to Mifare Plus, where only a few readers might support AES in the first place, it offers an optional AES authentication in Security Level 1. This does not prevent the attacks mentioned above but enables a secure mutual authentication between the reader and the card to prove that the card belongs to the system and is not fake. Mifare SAM Avenue 2. Mifare SAMs are not contactless smart cards. They are secure access modules designed to provide the secure storage of cryptographic keys and cryptographic functions for terminals to access the Mifare products securely and to enable secure communication between terminals and host. Mifare SAMs are available from NXP in the contact-only module as defined in ISO IEC 7816-2 and the HVQFN32 format. Key features: compatible with Mifare Portfolio Solutions, supports Mifare 3DES and AES cryptography, key diversification, secure download and storage of keys, 128 key entries, ISO IEC 7816 baud rate up to 1.5 Mbps, X-mode functionality. Integrating a Mifare SAM Avenue 2 in a contactless smart card reader enables a design which integrates high-end cryptography features and the support of crypto authentication and data encryption-decryption. Like any SAM, it offers functionality to store keys securely, and perform authentication and encryption of data between the contactless card and the SAM towards the back end. Next to a classical SAM architecture, the Mifare SAM Avenue 2 supports the X-mode, which allows a fast and convenient contactless terminal development by connecting the SAM to the microcontroller and reader IC simultaneously. Mifare SAM Avenue 2 offers AV1 mode and AV2 mode, where in comparison to the SAM Avenue 1 the AV2 version includes public key infrastructure, hash functions like SHA-1, SHA-224, and SHA-256. It supports Mifare Plus and a secure host communication. Both modes provide the same communication interfaces, cryptographic algorithms, and X-mode functionalities. Applications: Mifare products can be used in different applications: automated fare collection system, ID cards, access management, campus cards, loyalty cards, tourist cards, micropayment, mobile wallet, contactless payment, cashless payment, road tolling, transport ticketing, event ticketing, mobile ticketing, citizen card, membership cards, parking, library cards, fuel cards, hotel key cards, NFC tag, NFC apps, MIFARE4 mobile, taxi cards, smart meter, museum access cards, product authentication, production control, health cards, ferry cards, car rentals, fleet management, amusement parks, bike rentals, blood donor cards, information services, interactive exhibits, interactive lotteries, password storage, smart advertising, social welfare, waste management, foremost access. Systems used Mifare Classic, but today these systems switched to Mifare DSVIRE because this product has more security than Mifare Classic. History: 1994 Mifare Classic 1K contactless technology introduced. 1996 first transport scheme in Seoul using Mifare Classic 1K. 1997 Mifare PRO with triple DES coprocessor introduced. 1999 Mifare PROX with PKI coprocessor introduced. 2001 Mifare Ultralight introduced. 2002 Mifare DSVIRE introduced, microprocessor-based product. 2004 Mifare DSVIRE SAM introduced, secure infrastructure counterpart of Mifare DSVIRE. 2006 Mifare DSVIRE EV1 is announced as the first product to support 128-bit AES, 2008 Mifare Plus is announced as a drop-in replacement for Mifare Classic based on 128-bit AES. 2008 Mifare Ultralight C is introduced as pay-per-ticket IC featuring triple DES authentication. 2010 Mifare SAM Avenue 2 is introduced as secure key storage for readers AES, triple DES, PKI authentication. 2012 Mifare Ultralight EV1 introduced, backwards compatible to Mifare Ultralight but with extra security. 2013 Mifare Desfire EV2 is announced with improved performance, security and privacy and multi-application support. Mifare was developed by Micron. The name stands for Micron Fair Collection System. It was acquired by Philips in 1998. Micron sourced silicon from Atmel in the US, Philips in the Netherlands, and Siemens in Germany. Infineon Technologies, then Siemens, licensed Mifare from Micron in 1994 and developed both standalone and integrated designs with Mifare-compatible functions. Infineon currently produces various derivatives based on Mifare technology including 1K memory and various microcontrollers, 16-bit, and 32-bit with Mifare emulations, including devices for use in USIM with near-field communication. Motorola tried to develop Mifare-like chip for wired logic version but finally gave up. The project expected 1 million cards per month for start, but that fell to 100,000 per month just before they gave up the project. In 1998 Philips licensed Mifare to Hitachi. Hitachi licensed Mifare for the development of the contactless smart card solution for NTT's IC telephone card which started in 1999 and finished in 2006. In the NTT contactless IC telephone card project, 3 parties joined, Tokin Tamura Siemens, Hitachi, and Denso. NTT asked for 2 versions of chip, that is wired logic chip with small memory and big memory capacity. Hitachi developed only big memory version and cut part of the memory to fit for the small memory version. The deal with Hitachi was upgraded in 2008 by NXP to include Mifare Plus and Mifare Desfire to the renamed Semiconductor division of Hitachi Renesas Technology. In 2010 NXP licensed Mifare to Gemalto. In 2011 NXP licensed Bertha to use Mifare on SIM cards. These licensees are developing near-field communication products, security of Mifare Classic, Mifare Desfire and Mifare Ultralight. The encryption used by the Mifare Classic card uses a 48-bit key. A presentation by Henrik Pla Paragraph TZ and Carson Knoll at the Chaos Communication Congress in December 2007 described a partial reverse engineering of the algorithm used in the Mifare Classic chip. Abstract and slides are available online. A paper that describes the process of reverse engineering this chip was published at the August 2008 Usenix Security Conference. In March 2008 the Digital Security Research Group of the Radboud University Nijmegen made public that they performed a complete reverse engineering and were able to clone and manipulate the contents of an OV chip card which is a Mifare Classic card. For demonstration they used the Proxmark device, a 125 kHz/13.56 MHz research instrument. The schematics and software are released under the free GNU General Public License by Jonathan Walthius in 2007. They demonstrate it is even possible to perform card-only attacks using just an ordinary stock commercial NFC reader in combination with the LIB NFC library. The Radboud University published 3 scientific papers concerning the security of the Mifare Classic, a practical attack on the Mifare Classic, dismantling Mifare Classic, wirelessly pickpocketing a Mifare Classic card. In response to these attacks, the Dutch Minister of the Interior and Kingdom Relations stated that they would investigate whether the introduction of the Dutch RIGSPAS could be brought forward from Q4 of 2008. NXP tried to stop the publication of the second article by requesting a preliminary injunction. However, the injunction was denied, with the court noting that, it should be considered that the publication of scientific studies carries a lot of weight in a democratic society, as does informing society about serious issues in the chip, because it allows for mitigating of the risks. Both independent research results are confirmed by the manufacturer NXP. These attacks on the cards didn't stop the further introduction of the card as the only accepted card for all Dutch public transport. The OV chip card continued as nothing happened, but in October 2011 the company TLS, responsible for the OV chip card, announced that the new version of the card will be better protected against fraud. The Mifare Classic Encryption Crypto 1 can be broken in about 200 seconds on a laptop, if approximately 50 bits of known key stream are available. This attack reveals the key from sniffed transactions under certain circumstances and/or allows an attacker to learn the key by challenging the reader device. The attack proposed in recovers the secret key in about 40 miss on a laptop. This attack requires just one authentication attempt with a legitimate reader. Additionally, there are a number of attacks that work directly on a card and without the help of a valid reader device. These attacks have been acknowledged by NXP. In April 2009, new and better card-only attack on Mifare Classic has been found. It was first announced at the rump session of Eurocrypt 2009. This attack was presented at Secrypt 2009. The full description of this latest and fastest attack to date can also be found in the IACR preprint archive. The new attack improves by a factor of more than 10 all previous card-only attacks on Mifare Classic, has instant running time, and it does not require a costly pre-computation. The new attack allows to recover the secret key of any sector of Mifare Classic card via wireless interaction, within about 300 queries to the card. It can then be combined with the nested authentication attack in the Nijmegen Oakland paper to recover subsequent keys almost instantly. Both attacks combined, and with the right hardware equipment such as Proxmark 3, one should be able to clone any Mifare Classic card in not more than 10 seconds. This is much faster than previously thought. Fire attacks. In October 2011, David Oswald and Christoph Paar of Ruhr University in Bochum, Germany, detailed how they were able to conduct a successful side-channel attack against the card using equipment that can built for nearly $3,000. Called Breaking Mifare Fire MF3 ICD-40, Power Analysis and Templates in the Real World, they stated that system integrators should be aware of the new security risks that arise from the presented attacks and can no longer rely on the mathematical security of the US3DES cipher. Hence, in order to avoid, for example, manipulation or cloning of smart cards used in payment or access control solutions, proper actions have to be taken. On the one hand, multi-level countermeasures in the back-end allow to minimize the threat even if the underlying RFID platform is insecure. In a statement, NXP said that the attack would be difficult to replicate and that they had already planned to discontinue the card at the end of 2011. NXP also stated the impact of a successful attack depends on the end-to-end system security design of each individual infrastructure and whether diversified keys are recommended by NXP are being used. If this is the case, a stolen or lost card can be disabled simply by the operator detecting the fraud and blacklisting the card. However, this operation assumes that the operator has those mechanisms implemented. This will make it even harder to replicate the attack with a commercial purpose. Ultralight attack. In September 2012, a security consultancy Intrepidus demonstrated at the EUSec West event in Amsterdam that Mifare Ultralight-based fare cards in the New Jersey and San Francisco transit systems can be manipulated using an Android application, enabling travelers to reset their card balance and travel for free in a talk entitled NFC for Free Rides and Rooms. Although not a direct attack on the chip but rather the reloading of an unprotected register on the device, it allows hackers to replace value and show that the card is valid for use. This can be overcome by having a copy of the register online so that values can be analyzed and suspect cards hotlisted. NXP have responded by pointing out that they had introduced the Mifare Ultralight C in 2008 with 3DES protection and in November 2012 introduced the Mifare Ultralight EV1 with 3-decrement-only counters to foil such reloading attacks. Considerations for systems integration. For systems based on contactless smart cards, security against fraud relies on many components, of which the card is just one. Typically, to minimize costs, systems integrators will choose a relatively cheap card such as a Mifare Classic and concentrate security efforts in the back office. Additional encryption on the card. transaction counters, and other methods known in cryptography are then employed to make cloned cards useless, or at least to enable the back office to detect a fraudulent card, and put it on a blacklist. Systems that work with online readers only are easier to protect than systems that have offline readers as well, for which real-time checks are not possible and blacklists cannot be updated as frequently. See also, RFID, physical security, NFC, smart card, places that use Mifare technology, transportation, application references, institutions, Linköping University, Sweden, student staff ID, access control, library, copy print, student discount, payments, London School of Economics, access control, New College School in Oxford, building access. Imperial College London, staff and student ID access card in London, UK. Cambridge University, student staff ID and access card, library card, canteen payments in some colleges, University of Warwick, staff and student ID card and separate eating at Warwick stored value card in Coventry, UK. Regent's College, London, staff and student ID access card in London, UK. Bucknell University, student ID access card in Lewisburg, Pennsylvania. University of New South Wales, student ID access card. University of Alberta, staff one card trial currently underway. Northumbria University, student staff building and printer access. City University of Hong Kong, student staff building, library, amenities building. Hong Kong Institute of Vocational Education, student ID card, attendance, library, printers and computers access. University of Bayreuth, student ID card and canteen card for paying. University of Ibadan, Nigeria, student ID card and examination verification and attendance. Solutions Colony Limited, Bowen University, Iwo, Nigeria, student ID card and examination verification and attendance. Solutions Colony Limited, Afbe Balola University, Ado-Ekiti, Nigeria, student ID card and examination verification and attendance. Solutions Colony Limited, Achievers University, Awo, Nigeria, student ID card and examination verification and attendance. Solutions Colony Limited, Adekunle Jazin University, Akungba, Ondo State, Nigeria, student ID card and examination verification and attendance. Solutions Colony Limited, Auchi Polytechnic, Auchi, Nigeria, student ID card and examination verification and attendance. Solutions Colony Limited, University College Hospital, Ibadan, Nigeria, student ID card and staff attendance. Solutions Colony Limited, Federal University of Technology, Minna, Niger State, Nigeria, student ID card and examination verification and attendance. Solutions Colony Limited, Benson Idahosa University, Benin City, Edo State, Nigeria, student ID card and examination verification and attendance. Solutions Colony Limited, Federal University of Technology, Akure, Ondo State, Nigeria, student ID card and examination verification and attendance. Solutions Colony Limited, Covenant University, Nigeria, student ID card and examination verification and attendance. Solutions Colony Limited, Lead City University, Nigeria, student ID card and examination verification and attendance. Solutions Colony Limited, Hogeschool Universiteit Brussels, Belgium, student ID card, canteen card for paying, library and building access. Southampton University, student ID card, library and building access, Mifare Classic 4K, Delft University of Technology, Netherlands, student staff ID card, staff coffee machines, lockers, printers and building access. Dresden University of Technology, Germany, building access, canteen card for payment, Chemnitz University of Technology, Germany, student ID card, Leipzig University, Germany, student ID card, canteen card for payment, Freiburg University of Mining and Technology, Germany, student staff ID card, building access, canteen card for payment, University of Jena, Germany, Student Staff ID Card, Building Access, Canteen Card for Payment, Technical University of Denmark, Denmark, Student ID Card, Building Access, University of Duisburg-Essen, Germany, Student Staff ID Card, Library Access, Canteen Card for Payment, Disney Infinity, Figure and Power Disc Bases, Walt Disney World Resort, used for tickets, Disney. Dining Plan, and Room Key Access, University of Northampton, Car Park Access, Building Access, Mifare Classic 1K, Assumption University, Thailand, Student Staff ID Card, Library and Computers Access, Canteen, Transportation and Parking Payment, Election Verification, Mifare Classic 4K, References. Further reading, Dayal, Geeta, How They Hacked It, The Mifare RFID Crack Explained. A look at the research behind the chip compromise, Computer World, March 19, 2008. External links, official website, 24C3 Talk about Mifare Classic video of the 24C3 talk presenting the results of reverse engineering the Mifare Classic family, raising serious security concerns. Presentation of 24th Chaos Computer Congress in Berlin claiming that the Mifare Classic chip is possibly not safe. Demonstration of an actual attack on Mifare Classic by the Radboud University Nijmegen.